All right, so here's these exercises. Of course, you're doing these on your own before you get the answers from the video. If you're stuck on exercise 2, my advice is to go back to example 1, the second two parts here, where you knew the vertex, and try that. And if you're still stuck, come back and watch this. Same thing with exercises 3 and 4. Try them on your own. If you get really stuck, you can check out the answers in a bit. All right, so for exercise 2, we want to get a quadratic formula with vertex at -2, 8. So if we know the vertex, we can use that value of h and k here. The h is -2, so this is going to look like a times x minus -2 quantity squared plus k will be just plus 8. So it looks like that. But we don't know what the value of a is to really write out this formula in a regular way. So to get the value of a, we're going to use the y-intercept. So the fact that f of 0 is 7. Saying f of 0 is 7, well, let's write that formula out here. F of 0 means I'm going to take the 0 and plug it in for x, so that's going to look like a times 0 plus 2 squared plus 8. And so let's see, 0 plus 2 is 2. 2 squared is 4, so that will give you a times 4 plus 8 equals 7. We can subtract the 8 from both sides to solve this equation for a. Divide both sides by 4 here. We'll get a equals -1/4. So let's see, that should be a function now. To plug that back into the original thing, it's going to look like f of x equals -1/4 times x plus 2 quantity squared plus 8. And I don't care if you write it as x minus -2 or x plus 2. Either way is fine. And it's a good idea to check your answers here. You can go to Desmos and it's loading, and let's just type in what we just had. It was -1/4 times x plus 2 squared plus 8. Oops, -1/4 times x plus 2 squared plus 8. And let's see, does that have the vertex at -2, 8 here? Yes, it does. And does it have the y-intercept at 0, 7? Yes, it does. So that's what it was asking for. So that's a good way to check your results for these. You could also do that on your graphing calculator, of course. All right, so let's look at exercise 3. We've got a coin thrown upward at time t equals 0 seconds from the window of an office in the Empire State Building. This coin has height in feet above the ground t seconds later, given by this function. So you plug in a number of seconds after the coin was thrown and into this, and the result of working out this should give you the height. And there's two different versions of it here. If you were going to take this and FOIL everything out, the t times -16, you'd get this stuff. The -10 times 6 would be -60 times -16 would be 960. It should all FOIL out to be the same thing. So it's written in both formats here. Okay, so let's answer question A. So from what height was the coin thrown? Well, if it was thrown at t equals 0 seconds, then it's telling you it's telling you that t is equal to 0 at this time. So we want to know what h of 0 is. And let's see, which one of these is it easier to do the arithmetic with if you want to plug in h equals 0? Well, with the second one, we'd have to do 0 minus 10 and 0 plus 6, we'd end up having to multiply negative 16 times negative 10 plus times 6, excuse me. So you'd have to do some arithmetic with this one. With the first one here, if you plug in t equals 0, you know that 16 times 0 squared is 0. 64 times 0 is 0. You're just going to get 0 plus 0 plus 960. So that's just 960 feet at when it was thrown. Okay, so at what time does the coin reach the ground? Okay, so if it's telling you the coin reaches the ground, that tells you the height. The height is 0. T is unknown here. That's what we're trying to find, is what is that time. So we could either solve the equation negative 16t squared plus 64t plus 960 equals 0. See what t makes that true, but that would be hard. Or, you know, you could also write it in factored form here, which would be negative 16 times t minus 10 times t plus 6 equals 0. And which one of these is easier to solve? Definitely this one, the second one. Because when it's in factored form, you could just make t minus 10 equal to 0. That will give you t equals 10. Or this one will give you the value of t that makes t plus 6 equal to 0. Well, negative 6 plus 6 is 0. So this one would be t equals negative 6. Okay, now, but wait, if you have t equals negative 6, that would mean 6 seconds before it was thrown. This one doesn't make sense. This formula really only applies to values of t that are greater than 0, because it's about t seconds later, not seconds before. So that doesn't make sense here. But the t equals 10 does. That means 10 seconds later is when it reaches the ground. So those are the answers to that. Let's look at exercise 4 here. So we're given functions f of x equals a times the quantity x minus h squared plus k. And we want to know whether the constants h and k are positive, negative, or 0. So let's see. Remember that hk is the vertex. So let's see, where's the vertex here with A? The vertex is, well, let's see, the x coordinate is 0 because you're not going left or right at all. So in this case, it might be something like 0, negative 1 is a vertex, or maybe it's 0, negative 5. I don't have a scale here. Or maybe it's 0, negative 0.3 or something like that. But the vertex is something like that. But the important thing is the x-coordinate is 0 because you're on the y-axis. You're not going left or right at all. And the y-coordinate is negative because you're below the x-axis. So in this case, h equals 0. K is negative. It's less than 0. Okay, how about this one? Here's the vertex. So this time the x-coordinate is, of the vertex, it's to the right. So I don't know what it is. Maybe you have x equals 1, 2, 3, 0. I'm saying 0 because the y-coordinate is 0. You don't go up or down from the x-axis at all. Maybe it's 3, 0. I don't know exactly. Like maybe each of these tick marks is actually 2. Maybe it's 6, 0. Maybe each one of them is 0.1. So it's 0.3, comma 0. But either way, the y-coordinate is 0 because you don't go up or down at all. So that means the value of k must be 0. But the x-coordinate is positive. So h, the x-coordinate of the vertex, is positive. The y-coordinate is equal to 0. All right, let's look at exercise 5. We've got this time functions, if they're written in factored form like this, we've got x minus r times x minus s, excuse me. So remember, these are always going to have x-intercepts r0 and s0. So with this one, and we're also assuming r is less than or equal to s. So this might be the point r0 here. This would be the point s0. So in this case, and I didn't do it the other way around because it says r is less than or equal to s, so it must be over this way. Must be the r. So in this case, r is negative, and s is positive. Oh, and I forgot to say about a here. A is positive because it's opening upwards. Were these ones asking for a? No. But a should be positive with both of these. Okay, with this one, let's see. In this case, r and s must be the same. There's only one x-intercept, and it's actually at 0. So we only have the point 0, 0 here. So in this case, r equals s, it must be equal to 0. And how about the a? Well, this one's opening downwards. If it's opening downwards, the a must be negative. All right, now let's look at exercise 6 here. We want a quadratic function with this vertex and passing through the origin. So just like a bunch of the previous exercises, if you're given the vertex, you can write it in vertex form, like this one. But the h and the k here are going to be 3 and 9. Like so. So it should look like that, but we don't know what a is. So if it's passing through the origin means that 0, 0 is on it. So in other words, if you plug in x equals 0, the result is going to be 0, too. So let's make that work here. That's going to look like, scooch this frame down a second so I can get a little bit more real estate. Okay, so f of 0 is going to be what you get here when you replace x with 0. So that would be a times 0 minus 3 squared plus 9. And that result needs to become 0. So again, if the x is 0, the result y needs to be 0 if it's passing through the origin. Okay, so this is something we can solve. Negative 3 squared is 9, positive 9. So we're going to have a times 9 plus 9 is equal to 0. So this is an equation we need to solve for a to see what a makes this fact work. So we're going to subtract 9 from both sides. That will give you 9a equals negative 9. If you divide both sides by 9, you'll get a equals, my a's look like my 9, excuse me. A equals negative 1. Okay, so that's the value of a, so you can use that to finish off your formula here. It's going to be f of x equals negative 1 times x minus 3 quantity squared plus 9. And again, it's always a good idea to check this with something like Desmos or your graphing calculator. We have negative 1 times x minus 3 squared plus 9. And yeah, this has vertex at 3, 9 there. So that looks good. It also passes through the origin there. So this works. All right, those were pretty tricky problems. If you got through these, give yourself a pat on the back. If you needed to get some help, that's okay too. But as long as you're struggling through the math, and doing some things on your own, you're still going to be learning some math. All right. Have a good day. See you next time.